Let us understand about losses in transformers, losses in transformers and voltage regulation in transformer also, and voltage regulation. Let us understand what are the different types of losses we come across in a transformer, how they impact, and what is the role of voltage regulation. Generally, transformer losses are classified into two types. First one is core loss and the second one is copper loss. Core loss is also called as iron loss or constant losses. Copper loss is also known as variable losses or I square or loss. Let us understand what it is. Now we know that the core loss can be classified again into two types. First one is hysteresis loss, and the second one is eddy current. Now hysteresis loss, if I represent as I, so Wi is your total iron loss. It has two losses, that is WH hysteresis and W is eddy current losses. What is hysteresis loss? Due to hysteresis effect, there is a loss of energy as a magnetic core goes through a cycle of magnetization and demagnetization. As we know that in a magnetic field, magnetization and demagnetization do happen. Because of that, there is a loss of energy. So, and it is represented as KH Bm to the power of 1.67 F into V, where KH is your hysteresis constant and Bm is maximum flux density, F is the frequency and V is the voltage of the core. Hysteresis losses can be minimized by using a high grade coarse material like silicon steel. Now also eddy current loss is also related with the core. So here the induced EMF in the core, which is induced in the core, sets up an eddy current in the core. Because of this additional eddy current, there will be some energy loss in the form of heat, which is called as eddy current loss. So eddy current loss we can represent W is equal to KE Bm square F square T square, where Ke is eddy current constant, T is the thickness of the core. So eddy current loss also can be minimized by using a thin laminations in the transformers. Now coming to the second loss, that is copper loss. So copper loss depends upon the amount of load. So we can say it is due to the power which is wasted in the form of I square R loss to the primary and secondary winding of the resistance. So we can represent WC is equal to I1 square R1 in the primary and also I2 square R2 in the secondary. Now when the copper loss is referred to the primary side, so we can say WC is equal to I1 square. So R1 can be R1 plus R2 dash. Similarly, with respect to secondary, I2 square R1 dash plus R2. Now from the above this equation, we can say that copper loss is directly proportional to I square and also KVA square. So that is WCU is proportional to I square and it is further proportional to KVA square. Now what happens here? As the current changes, copper loss also changes. Hence, it is called as variable loss. The copper loss also can be minimized by designing the winding with low resistance. So this is about iron and copper losses. Now coming to voltage regulation. What is a voltage regulation? So voltage regulation can be defined as change in the ratio of no load to full load voltage, that is V regulation, is equal to change in load from no load to full load E2 minus V2 divided by V2 into 100. E2 is the no load voltage, V2 is the voltage when we apply the load on the machine. Load means basically current. So whenever we change the current, the voltage of the transformer should remain constant, but because of the applied load, voltage tends to deviate or change. That phenomena itself is called as voltage regulation. Thank you.